Hello everyone. So, in the last lecture we were studying about properties of Laplace transform. Some of the properties we have seen like shifting property, first shifting or first translation or shifting property, then we see second translation or shifting property, some problems based on this that we have seen in the last lecture. So, now we will see some more properties of Laplace transforms in this lecture. So, the next property is change of scale property. Now, what this states? It states that if Laplace transform of some ft is fp, then Laplace transform of fat is nothing but 1 by a fp by a. Of course, a should not equal to 0. So, this is called change of scale property. Now, how we will prove it? So, the proof is very simple, simply based on the definition of Laplace transforms. So, what is Laplace transform of fat? It is nothing but 0 to infinity e की power minus pt fat dt. Now, you can substitute at equal to some new variable z. So, a dt will be equals to dz. So, when you substitute this thing over here, so when t is 0, z is 0, so it will be 0. When t tend to infinity, z will tend to infinity, so it is infinity e की power. Now, t is nothing but z by a, so it is minus p into z upon a into f of z, and dt is nothing but dz upon a. So, it is 1 upon a times dz. So, this quantity is nothing but 1 by a 0 to infinity e की power minus p z upon a fz into dz. Or we can write it like this: 1 upon a integral 0 to infinity e की power minus some zeta times p into fz dz, where zeta is nothing but p upon a. Now, when you compare this with Laplace transform ft, so Laplace transform ft is given by a 0 to infinity e की power minus pt ft dt, and this we are calling as fp. This we are calling as fp because p is a parameter, so is a function of fp. Now, here the same thing is same thing what we have in this expression. So, this can also be written as, this expression can also be written as 0 to infinity 1 upon a times e की power minus zeta t p into f t dt. So, that is nothing but 1 upon a f zeta, because instead of okay, it is z, because variable is z. So, it is z. So, now z is here. So, instead of it is t, now t is here. So, instead of p we have xi here. So, it will be f xi. So, what is xi? It is 1 by a f of p upon a. So, that is a proof of change of scale property, that is Laplace of f at is nothing but 1 by a f of p by a. Now, we will see some problems based on this. Suppose it is given to us that Laplace transform of ft is nothing but 1 by p square plus 1, and we have to find Laplace transform of e की power minus 2t into f of 3t. Now, there are two ways to solve this problem. The one way is you find the Laplace inverse of this fp, this is fp, you find the Laplace inverse of this Fp, that will be nothing but Ft. Find f of 3t, and then f of 3t will be find, and then using shifting property you can find Laplace transform of e ki power minus 3t f 3t. And second way is you apply change of scale property and then the shifting property to directly find out the Laplace transform of this expression. Now, how we can find the Laplace inverse of this? Again using partial fractions. This is nothing but some a upon p plus bp plus c upon p square plus 1. So, 1 is equals to a into p square plus 1 plus bp plus c into p. So, when you take p equal to 0, this implies 1 is equals to a. So, a is nothing but 1. Now, you compare the coefficient of p square. Here p square is 0, here p square is a plus b. So, this implies b is minus a and hence is equals to minus 1 because a is 1. Now, for c you can compare the coefficient of p. Here p coefficient is only this, which is c, and here there is no coefficient involving p. So, 0 equal to c. So, c must be 0. So, what are the partial fraction of this expression? 1 by p into p square plus 1. The partial fraction will be nothing but a is 1. So, it is 1 by p plus b is minus 1 and c is 0. So, it is minus p upon p square plus 1. So, this is the partial fraction of this Fp. So, what will be Laplace inverse of this? So, by the linearity property of Laplace inverse, this is nothing but Laplace inverse of 1 by p minus Laplace inverse of p upon p square plus 1, and this is nothing but 1 minus cos t. So, this is Ft. Laplace inverse of Fp is nothing but Ft. Now, we have to find out first f3t. So, what will be f3t? It is nothing but 1 minus cos 3t, and Laplace of e ki power minus 2t into f3t will be nothing but, first we will find out Laplace transform of f3t, that will be new Fp, and in that new Fp we will apply shifting property. So, what is Laplace transform of f3t? Which is nothing but 1 by p minus 3 upon p minus p upon p square plus 9, where cos at is nothing but Laplace of cos at is p upon p square plus a square. So, Laplace of, so this is, this we are taking as suppose gp, function of p, suppose it is gp. So, Laplace of f3t is gp, then Laplace of this expression will be nothing but g, you replace p by p minus a, here a is minus 2. So, it is nothing but p plus 2. So, that is nothing but 1 upon p plus 2 minus p plus 2 upon p plus 2 whole square plus 9. So, if you take LCM and simplify, so it is clearly visible that it is nothing but p plus 2 into p plus 2 whole square plus 9. So, that will be the Laplace of e ki power minus 3t into f3t, e ki power minus 2t into f3t. So, this is the one way. Now, finding Laplace inverse of given Fp, this Fp is very simple. So, we have taken the partial fraction and simply computed, first computed Laplace inverse of this Fp, let us suppose it is Ft, and then using shifting property we have find the Laplace transform of e ki power minus 2t into f3t. Now, if you have a complicated expression, so finding Laplace inverse is a difficult job, I mean is a time consuming job. So, for this particular type of problems we can solve directly also using a first change of scale property and then using shifting property. How? Now let us see. So, this is suppose Fp, okay, this is suppose Fp. Now what is Laplace of f3t? It is nothing but 1 by a, f a here is 3. So, 1 by 3 f of p by 3. So, it is nothing but 1 by 3 1 upon p by 3 into p square by 9 plus 1. So, that is nothing but 3 cancels out, okay. This is p by 3 and this is 1 by 3, okay, this is 1 by 3. So, this is 1 by 3 into, so this is 3 into 9 upon p into p square plus 9. So, this 3 cancels out. Now, what is Laplace of e ki power minus 2t f3t? So, this is suppose this is some GP function of p, suppose this is GP. So, Laplace of e ki power at and some ft will be nothing but by shifting property, it is f of p minus a. Here Laplace of this function is GP. So, we have to apply shifting property for this function. So, this will be nothing but by the shifting property it is p plus 2, because here a is minus 2. So, it is nothing but 9 upon p plus 2 into p plus 2 whole square plus 9. So, that is how using change of scale property and shifting property we can find the Laplace transform of this particular problem very easily. Okay. Now, let us find out Laplace transform of some special functions, special functions like Bessel function. So, I am not going into much detail of special functions, simply assume that j naught x is given by this series and error function is given by this particular expression. So, how to find Laplace transform of j naught t, which we call as Bessel function, and how to find Laplace transform of error function. So, let us try to find out this thing, and then once we find the Laplace transform of Bessel's function, which is j naught t or error function, we can solve those two problems using shifting property and change of scale property. So, let us find first j naught t. So, j naught t is nothing but 1 minus t square by 2 square plus t ki power 4 upon 2 square into 4 square minus t ki power 6 upon 2 square 4 square into 6 square and so on, as given in the problem. Okay. So, what is Laplace transform of j naught t? Now, Laplace transform of 1 is 1 by p, Laplace transform of t square is factorial 2 upon p square into 2 square, Laplace transform p cube, it is because Laplace transform of t ki power n is what? Is nothing but factorial n upon p ki power n plus 1, if n is 1, 2, 3 and so on for integer, for positive integers. So, again it is factorial 4 upon p ki power 5, 2 square into 4 square minus factorial 6 upon p ki power 7, 2 square, 4 square, 6 square and so on. So, it is nothing but 1 by p, take 1 by p common. So, it is 1 minus 1 2 cancels out. So, it is 1 by 2 p square, then it is nothing but 4 into 3 into 2 into 1 upon p ki power 4 into 2 square into 4 square minus, it is nothing but 6 into 5 into 4 into 3 into 2 into 1 upon p की power 7 p की power 6 because 1 p is common. So, and it is 2 square, 4 square and 6 square and so on. Now, 1 2 2 cancel out, 1 4 4 cancel out. So, we have observed that numerator always contain odd terms and denominator always contain even terms. That is, it is nothing but 1 by p minus 1 by 2 p square plus 1 into 3 upon 2 into 4 into 1 by p square का whole square. It is nothing but minus 1 into 3 into 5 upon 2 into 4 into 6 into 1 by p square का whole cube and so on. Okay. So, this is nothing but 1 by p into में, this is 1 by p into, so 1 by p into. Now, this is 1 minus, this is nothing but you can say plus minus 1 by 2 into p, 1 by p square. Now, this is nothing but minus 1 by 2 into minus 1 by 2 minus 1 upon factorial 2 into 1 by p square. When you simplify this expression, so what we get? It is minus 1 into minus 3 when you take LCM. So, 1 into 3 minus minus plus and 2 cube. So, 2 cube is in the denominator. Okay. Next is, it is plus minus 1 by 2 minus 1 by 2 minus 1 into minus 1 by 2 minus 2 upon factorial 3 into 1 by p square का whole cube. So, again it is nothing but when you simplify, so you will get back the same expression. It is 1 into 3 into 5 upon 2 cube into factorial 3, which is nothing but 2 into 4 into 6. So, what this expression is basically? This is nothing but 1 minus 1 by p 1 plus p square की power minus half. This is by the binomial theorem, 1 plus mx plus m minus 1 upon factorial 2 into x square and so on. So, now this is nothing but when you simplify, this is 1 by p into p square plus 1 upon p square whole power minus half, which is nothing but 1 upon p square plus 1 का under root. So, this is the Laplace transform of J naught t, which we are calling as Bessel function. Okay. So, you simply open the series, this series is given to you, you take the Laplace transform both the side, simplify. So, this will be reduced to some binomial expansion of 1 plus 1 by p square whole की power minus half, and when you simplify we will get 1 upon under root p square plus 1 as the Laplace transform of J naught t. Now we can solve first problem. Since now we know Laplace transform of J naught t, so what will be the Laplace transform of J naught 2t first? So, this is using change of scale property, because if Laplace transform f t is some f p, then Laplace transform of f a t is nothing but 1 by a f p by a. So, here this is f p, and this is Laplace transform of J naught t. So, what will be Laplace transform of this? Here it will be 1 by 2 f p by 2. So, this is nothing but 1 by 2 f of 1 by under root p by 2 का whole square plus 1, which is nothing but 2 upon 2 under root p square plus 1 p square plus 4. So, it is nothing but 2 to cancel out. So, it is 1 upon under root p square plus 4. So, what will be Laplace transform of e की power minus 3t of this? J naught 2t, this will be equal to. Now, let us suppose this is Gp. the Laplace transform of J naught to t. Let us suppose it is Gp. So, Laplace transform of e ki power minus 3t into this is nothing but, by using shifting property, it is g of p plus 3, because in the Laplace transform of this J naught to t, you replace p by p plus 3. So, Laplace transform of this is Gp. So, you replace p by p minus a, and a is minus 3. So, it is nothing but 1 upon under root p plus 3 whole square plus 4. So, this will be the final answer. You can simplify, and that will be the Laplace transform of e ki power minus 3t J naught to t. Now, let us find out Laplace transform of error function under root t. So, and then using change of scale property we can solve that problem. So, what is Laplace transform of error function? Let us see. So, error function, what is error function of under root t? How we define it? It is nothing but 0 to under root t, 2 upon pi times 0 to under root t e u square e ki power minus u square du. So, now it is equal to 2 upon under root pi 0 to under root t. Now, we know the expression of e ki power minus x. We can use this expression here, it is 1 minus u square upon factorial 1 plus u square ka whole square upon factorial 2 minus u square ka whole cube upon factorial 3 and so on into du. So, this is nothing but 2 upon under root pi. So, integral of 1 will be u, and when you apply upper limit is it is under root t. Okay. So, when you apply upper limit minus lower limit, so this will be nothing but under root t minus. Now, integration of u square is u cube upon 3. So, u cube, and when you apply upper limit minus lower limit is nothing but t ki power 3 by 2 upon 3 into factorial 1 plus u ki power 4 ka integral is u ki power 5 upon 5, and when you apply the limit is t ki power 5 by 2 upon 5 factorial 2. Similarly, here it will be u ki power 6, that is t ki power 7 by 2 upon 7 factorial 3 and so on. So, this will be the expression of error function in the series form. Now, when you take Laplace transform of e ki error function of under root t, so this will be nothing but 2 upon under root pi, you can take common, and this is nothing but gamma 3 by 2 upon 3 by 2 upon p ki power 3 by 2 minus it is gamma 5 by 2 upon 3 into factorial 1 into p ki power 5 by 2, okay, plus gamma 7 by 2 upon 5 into 2 factorial into p ki power 7 by 2 and so on. This is nothing but again 2 upon under root pi, take gamma 3 by 2 common and p ki power 3 by 2 common from the entire expression, from the entire series. Now, gamma 3 by 2 is nothing but 1 by 2 under root pi. This we know as gamma n plus 1 is n gamma n. So, this is 1 by 2 under root pi, this I have taken common, and also I have taken p ki power 3 by 2 as common, this is nothing but 1 minus. Now, gamma 5 by 2 is 3 by 2 gamma 3 by 2, gamma 3 by 2 are already common, so it is 3 by 2 into 3 into factorial 1 and p ki power 3 by 2 is common, so it is p, okay, plus. Now, gamma 7 by 2 is 5 by 2 gamma 5 by 2, and gamma 5 by 2 can be again written as 3 by 2 gamma 3 by 2. So, it is nothing but 5 by 2 into 3 by 2 gamma 3 by 2 which is common and upon 5 into factorial 2 p की power 2 and so on. Now again let us simplify this expression. 2 cancels out, this is cancels out, 1 upon p की power 3 by 2 and it is 1 minus this 3 cancel out, so it is 1 minus 1 by 2 p plus this 5 cancels out, it is nothing but 1 into 3 upon 2 into 4 upon 1 by p ka whole square and so on. So it is something the same expression which we arrived in the derivation of Jacobian derivation of Bessel function j naught t. So it is something like that. So we can also write this as 1 upon p ki power 3 by 2, 1 remain 1 minus this. So this can be written as minus 1 by 2 minus 1 by 2 minus 1 upon factorial 2 into 1 by p square and so on. Similarly, the other expressions can be write in the same way. So it is nothing but 1 upon p ki power 3 by 2 1 plus 1 by p whole ki power minus half. In that expression we have a binomial series of 1 plus 1 by p square ki power minus half. Here we have a binomial series of 1 plus 1 by p ki power minus half. So when you simplify it, so it is nothing but 1 upon p ki power 3 by 2 into p ki power half upon under root p plus 1. So it is nothing but 1 upon p under root p plus 1. So this is the Laplace transform of error function of under root t. This is how we can find out Laplace transform of error function of under root t. Okay. Now we can solve that problem very easily because we know the Laplace transform under root t, which is given by this fp. Now Laplace transform of 2 under root t, we can use change of scale property. It will be 1 by 2 fp by 2. If it is fp, so Laplace transform of error function of 2 under root t will be nothing but 1 by 2 f p by 2. This is by the scale property, change of scale property. So we can use this. So it is 1 by 2 p by 2 under root p by 2 plus 1. So this will be the Laplace transform of that expression. Now the next problem, let us first find Laplace transform ln x. What is ln x? ln x is Laguerre polynomial. Okay. So we are not going into the detail of this, but ln x is given by this particular expression, this expression. The expression is called as ln x. Let us try to find out the Laplace transform of this, and again using shifting property or scaling property, we can find out the Laplace transform of this expression. So let us try to find out the Laplace transform ln x. Then the rest of the part you can easily solve yourself, that how can you find out Laplace transform of e ki power 2 minus 2t ln 3t using shifting or scaling property. So what is ln x? ln x is given by, it is e ki power x upon factorial n, nth derivative of x ki power n e ki power minus x. So Laplace transform of ln x by the definition of Laplace transform is nothing but 0 to infinity e ki power minus pt into e ki power x upon factorial n, nth derivative of this into x ki power n e ki power minus x. So we have to use one symbol because here t is involved. So we have to define this in terms of t. ln t. Because Laplace transform f t we are defining. So, we have to express ln t in terms of t. So, this is expression for ln x. So, we can reduce in terms of t, replace x by t. So, how can you find out Laplace transform of this function? So, this is nothing but 1 by factorial n can be taken out. So, it is 0 to infinity e की power minus p minus 1 times t into nth derivative with respect to t की power n e की power minus t into dt. Now, you can make use of integration by parts. So, let us suppose this is first function and this second function. So, first as it is integration of second, it is n minus 1 derivative now. Integration 0 to infinity of this expression minus integration derivative of first integration of second, because integration is antiderivative. So, derivative powers will reduce. Now, when t tends to infinity, because this have negative powers and we are assuming p greater than 1, we can assume. So, this will tend to 0. So, and hence the entire term will tend to 0. And when t tend to 0, this is 1, and since it has a in the n minus 1 derivative of this function, all the terms involve at least 1 power of t, because here the highest power of t is t की power n, and when we differentiate n minus 1 times of this product of function, so all the terms will involve at least t की power 1. So, when you take t equal to 0, that value will be 0. So, this is 1 by factorial n into 0 minus. Now, minus minus plus, so it is p minus 1 times integral 0 to infinity e की power minus p minus 1 times t n minus 1 derivative of this expression into t की power n e की power minus t into dt. Now, t की it is dt, sorry, it is dt because we are differentiating with respect to t now. So, it is dt. So, so we have observed that in the integration of this, p minus 1 comes out when we integrate first time 1 times, and n minus 1 derivative will come here. So, if we repeat this process n times, so then we will be having if we integrate again for second time, take this as a first function, this is second function, again we will take one power of p minus 1, one more power of p minus 1 outside the bracket, so that is p minus 1 whole square will be here. Now, when we integrate this expression n times, so this will be nothing but power n, and it will be involved 0 to infinity e की power minus p minus 1 times t, and there will be no derivative of this expression. So, t will be t की power n e की power minus t into dt. So, this will be nothing but is equals to 1 by factorial n, this will be nothing but now right here. So, this expression will be nothing but 1 by factorial n p minus 1 की power n into, now e की power t and t cancels out. So, this will reduce to Laplace transform of t की power n, and so this is equals to 1 by factorial n p minus 1 की power n, and Laplace on this is nothing but factorial n upon p की power n plus 1, because n is an integer. So, these two cancels out. So, hence we have shown that Laplace transform of ln x is p minus 1 ki power n upon p ki power n plus 1. Now using scaling property and shifting property we can solve the remaining part. Now Laplace same property, that is change of scale property, we can read in terms of inverse also. If Laplace inverse of f p is f t, then Laplace inverse of p f p by a is nothing but a f a t if a is not equal to 0. Now these problems we can easily solve using this property. Suppose first problem we want to solve. So Laplace inverse of f p is given to us is e ki power t sin under root t, and you want to find out Laplace inverse of f 2 p. So when you compare with this, a is nothing but 1 by 2, a is nothing but 1 by 2. So you simply replace a by 1 by 2. So that means Laplace inverse of f 2 p will be nothing but 1 by 2 f t by 2, because a is half and this expression is f t. So what will be the Laplace inverse of this expression? So Laplace inverse of this expression will be nothing but here a is 1 by 2, so it is 1 by 2 f t by 2. So it is 1 by 2, f t is this, so it is e ki power t by 2 and sine under root t by 2. So using the same property we can solve the other two problems also. It is very easy, you take 9 common or 4 common and then you can use scaling property to solve these two problems also. So thank you very much.